Good morning, students. In the last class, we discussed about the how the modern periodic table genesis from the four laws. Okay, law of triads, law of octaves, Mendele's periodic law, and the modern period. So, in the today's class, we are going to elaborately study about the modern periodic table. So, this modern periodic table is also called as long form of periodic table. Why? Because so it explains successfully about all the properties, all the trends, everything in the periodic table. So that's why it is called as long form of the periodic table. Understand? So another thing is, listen. In the modern periodic table, four different blocks are there. One is S block, another one is P block, next one is D block, and last one is F block. Okay, four different blocks are there. S block, P block, C block, and F block. How these SPDF blocks are classified means. Okay, so why S block elements means, for example, lithium, sodium are belongs to only S block. Why boron are belongs to only P block. Why scandium those belongs to only D block. And why that uranium are belongs to F block. Everything is explained clearly in the periodic table. That's why it is called as a long form of the periodic table. Okay, so here we will discuss one by one. So I will start with the S block element. So the general configuration, their oxidation state, what happens to the metallic character, everything. Okay. So students, in S block, two groups are there. Okay. So in the periodic table, if you take this, at the extreme left of the periodic table, two groups are there, group 1 and group 2. Okay, so these groups are called as S block elements. Understand? So here the elements are hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. Okay, next here beryllium, magnesium, calcium, strontium, radium. Here, francium and radium are the radioactive elements, except these two, all are metals. Understand? Francium and radium are the radioactive elements, except these are all called as what? S block elements. This is also S block element, but these two elements doesn't show the properties of the S block element which are exhibited by the remaining elements, because as being they are radioactive element, they have the half-life period. So a certain half-life period, they change their concentration. Correct? So that's why they didn't show, these two didn't show the exacting properties of these elements. Understand? So these two are which type of elements? Radioactive elements. And this one is a liquid metal. Cesium is liquid metal which is blue in color. Still now we know only the liquid metal is mercury. Correct? But cesium also a liquid metal, it is blue in color. Understand? So next, as we come to the electronic configuration. So students, along the period, you know, in the yesterday's class I told 7 periods are there, 18 columns are there, those are called as groups. So here, this is the first, second, third, fourth, fifth, sixth, 7 period. Okay, so this 1, 2, 3, 4, 5, 6, 7 represents main shell, that is NS122 like that. N represents what? Number of periods where the element present. If you write the electronic configuration of hydrogen, you will get 1s1. If you write the electronic configuration of beryllium, you will get 1s2, 2s2. This 1, 2 represents what? In which period it exactly belongs. Listen, here calcium is there, its atomic number is 20. Okay, if you write the configuration 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Okay, so here the last electron enters into S subshell, that's why it belongs to S group. Understand? And at the same time, it belongs to fourth period. That means this shows the period which the element belongs. The N means what? Number of period in which the element is present. So here for hydrogen, as I told you, 1s1 means it is the first period. Okay, so beryllium atomic number is 4. As I told you, 1s2, 2s2 means it belongs to second period. Understand? So potassium you take, that is potassium. Sodium you take, that is 1s2, 2s2, 2p6, 3s1. Means it belongs to third period. Okay, this N represents the 1, 2, 3, 4, that is the number of periods. Or a number of period in which the element is exactly present. And students here, what happens to the electronic configuration? Along with, listen, here sodium I take means it ends with NS1. Hydrogen I take means ends with NS1. Calcium I took means here it ends with NS2, here S2. So along the group, they represents how many electrons are present in the subshell. That is a valence electron. Understand? So along the group, we can justify the valence electronic configuration. Understand? So the first group, the configuration is NS1. For second group, configuration is NS2. Understand? The first group, the group configuration is NS1. Second group configuration is NS2. Understand? So that means what it explains, in a first group element, the valence electrons are 1. Okay? In the second group, valence electron is 2. In the second group, in the first group. So it has the capacity to lose 1 electron, so its oxidation state is +1. Okay? So these second group elements have the capacity to lose 2 electrons, so it is +2. Understand? And at the same time, students, you know, if you want to combine this Na with Cl, means you write as NaCl. Because this is +1 charge, this is -1 charge, correct? Similarly, if you take Mg, if you want to combine with this Cl, you write it as what? MgCl2. Correct? Because it is +2 charge, to balance it, we want 2 Cl atoms. Understand? That means the second group elements always exhibit +2 oxidation state. The first group elements always exhibit +1 oxidation state. That is what? By the removal of electrons. So if there may be a question, you may think, why only loss of electron takes place? You know, Cl I said -1. Why not Na is -1? Why not Cl is +1? Like that, the question may arise in your mind. So the thing is, if we consider the confused, listen, here helium is there. After helium, lithium, sodium, potassium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. Here neon is there. Okay, so listen students, here its configuration is 1s2 and its configuration is 1s2, 2s2, 2p6. Okay, so in between these two local gas, these elements are exist. Okay, why these elements loss of electron means remove the electrons? Why these elements prefer accepting the electron? I will explain. So atomic number of lithium is 3. This one is 4, 5, 6, 7, 8, 9. Okay, I'll write only the valence electron. Like I left 1s2 here. So after 1s2 it is 2s1. Correct? 1s2, 2s1 means 3. Next 1s2, 2s2 for 4. 1s2, 2s2, 2p1 for boron. 1s2, 2s2, 2p2 for carbon. Are you getting? Okay, I am completely writing the electronic configuration of these elements. Understand? So here 1s2, 2s2, 2p3. This is 1s2, 2s2, 2p4. This is 1s2, 2s2, 1s2, 2s2, 2p5 of this here configuration. Later 1s2, 2s2, 2p6. Correct? That's what I wrote. So students, the thing is, either by loss of electron or by gain of electron, these elements should attain a 8 electron system. Or by loss of electron or gain of electron, they should attain a noble gas configuration. If it is not 8 electron also, it should attain what? Noble gas configuration. Here helium is the nearest noble gas, here neon is the nearest to noble gas. Okay? Compare in between these two. Understand? Here lithium is there, that is 2s1. Okay? So to attain this helium configuration, if it lose one electron, it attain helium configuration. Like 1s2 2s1 is there. If we remove one electron, then it is 1s2. So by loss of electron, it attain helium configuration. To attain neon configuration, it requires 1, 2, 3, 4, 5, 6 extra, 7 extra electrons. 2s1 is there. To attain 2s2, 2p6, it requires 7 extra electrons. So the energy required to remove one electron is very less compared to the energy required to add 7 electrons. Understand? So always, which one is the preferable and reaction means or whatever in the universe, the preferable is one which possesses a minimum energy. That is called as stable, correct? One which has a minimum energy, that is called as a stable compound. So here it requires less energy to remove electron and more energy to gain electron, means the loss of electron prefers. Understand? So it always prefers loss of electrons, so it is +2. Similarly, here if it loses 2 electrons, it attains helium configuration. If it if it want to exhibit neon configuration, it requires extra 6 electrons. So as comparing the energy, it also prefers loss of electron. And here boron also prefers loss of electron. So students, carbon, if we consider carbon, so here to attain helium configuration, it has to lose 4 electrons. To attain neon configuration, it has to gain 4 electrons. So that's why the energy required to remove 4 electron, energy required to add 4 electron, both are equal. Understand? That's why this boron exhibit both oxidation state, like plus or minus. Understand? It exhibits both plus or minus oxidation state. And next, nitrogen is here 2s2 2p3. Okay, so 5 valence electrons are there. To attain helium configuration, we have to remove 5 electrons. To attain neon configuration, we have to add extra 3 electrons. Which one is most preferable means instead of removal of 5 electron, addition of 3 electron is most preferable. Understand? So that's why the addition of 3 electron means electron is a minus charge. Removal means listen, electron is a minus in charge, negative charge. So we remove electron means plus charge will left. So addition of extra electron, 3 electrons we are adding means to the 0, extra 3 electrons means minus 2. Similarly here, minus 2, minus 1. Understand? That's why these exhibit the oxidation state +1, +2, +3, plus or minus 4, minus 3, minus 1, minus 1. This is the valency of electron, how it comes. Why these alkali and alkaline alkalines prefer this +1 and +2 oxidation state is because by loss of electron they easily attain noble gas configuration. Understand? Last, noble gas configuration is very, very important. And next, right. This is first group, this is second group. So I'll write here student, the general electronic configuration of first group is NS1, the second group is NS2. This is general electronic configuration. Next, valence electron. Here it is 1, here it is 2. Okay, this table is important. Okay, next, oxidation state. This is +1, this is +2. Understand? And the next one is These are called as alkali metals. These are called as alkaline earth metals. Okay, so these are called as alkali metals, the first group elements, and second group elements are called as alkaline earth metals. Why? So listen. Because why they are called as alkali metals means alkali is the Greek word that means base. Alkali is a Greek word that means base. Base means what? Which pH is greater than 7. Okay, or it may consist of OH minus ion. So those are called as bases. So always students, if you write Na as a base means you consider NaOH or KOH, right? Or you may write it as MgOH twice and CaOH twice. I hope you remember these formulas in the 10th standard only, okay? You already wrote in that. So NaOH is there, KOH is there, MgOH twice, KOH twice. So why these are called as alkali and alkaline earth metals means because they form strong bases. Okay, alkali means a Greek word that is base. These elements forms a strong bases. That's why they are called as alkali metals and alkaline earth metals. So why these called as alkali earth metals means because those metals are available in earth crust. Okay, so these second group elements, whether it is the barium, magnesium, calcium, strontium, those are all available in what? Earth crust. That's why they are called as alkaline earth metals. Understand? So this is all about the S block element. So S block element, its general configuration, complete S block general configuration is NS1 to 2. In that two groups are there. One is first group, another one is second group. Okay. First group elements are called as alkaline earth metal. Second group elements are called as first group elements are called as alkali metals. Second group elements are called as alkaline earth metals. The reason is because they form a strong basis. Understand? And next, the general electronic configuration of only first group is NS1 and its valence electron is 1 and its oxidation state is +1. Okay, so the general electronic configuration alone, second group is NS2 and its valence electron is 2 and oxidation state is +2. Okay, so this is for S block, and remember students, among these cesium is a liquid metal which is blue in color, and francium and radium are what? Radioactive elements. Okay, remember that these two are radioactive elements. Okay, so this is S block. Now we will study about P block elements. Here I write general electronic configuration NS1 to 2. Complete S block. Okay. Next, I write P block here. You know. So here, boron, carbon, nitrogen, oxygen, fluorine, neon, here helium is there. Okay, so here boron, aluminium, indium, gallium, thallium, and here atomic number greater than 100. That is UUT 113 element. Understand? That is I written as UUT. That means 113. Element with atomic number 113. Okay, it's carbon, silicon, germanium, tin, lead. So this is UUQ 114. Next, nitrogen, phosphorus, arsenic, antimony, bismuth, UU. Oxygen, sulfur, selenium, tellurium, polonium, and UUH. 1160. Okay. It's chlorine, chlorine, bromine, iodine, astatine, and UUS. Okay. Last one, neon, argon, krypton, xenon, radon, and UUO. Okay, this is P block element. Start from this is 2p, 3p, 4p, 5p, 6p, and 7p. Understand? So P block element is start from second period. First period elements only hydrogen and helium. Second group start from lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. So you have to remember the elements according to blockwise. Not like hydrogen, helium, lithium continuously. You can't remember. Okay, according to blockwise you may remember. Understand? So your S block element is there. Your P block element is there. So students, the P block element group starts from 13, 14, 15, 16, 17, and 18. Okay, so group 13 to group 18 are called as P block elements. And remember, both S and P block elements are called as main block elements in the periodic table. Both S and P block. Because the valence electron always depends upon the Ns and p orbital. Like Ns2 you know, and NP6 you write. That shows the completion of the electronic configuration. That is the valence configuration. Understand? So why these S and P block elements called as main block elements means because they tells about the valence electrons either as or P. Understand? So here students, general electronic configuration if you want to write means the general electronic configuration of P block is Ns2 Np1 to 6. Maximum electrons to be filled in p orbital is 6 because 1, 2, 3, 4, 5, 6 groups are there. So if we arrange in the increasing order of the atomic number means here each number goes on increasing means there may be a possibility of 6 electrons in the p orbital. So here the going S block only 2 means here only 2 groups. 2 groups are there means only 2 electrons can fill in the S block. Here 6 groups are there, 6 electrons. Understand? And remember, so individually if you want to write the electronic configuration, so consider here configuration, general configuration is Ns2, Np1. Whether it is boron, aluminium, indium, gallium, thallium, you may easily consider boron is 1s, 1p1, sorry 2p1 means this will be 3p1, 4p1, 5p1, 6p1. Understand? Always the first electron Np1 configuration will be there in the 13th group elements. If you consider the second carbon family, that is 14th group configuration is Ns2, Np2. As I told you, the group tells about what? Valence electronic configuration. This N tells about what? Period. Okay, this is 2p1. N means it belongs to second period. P1 means it belongs to 13th group. Next Np2. N is 2 means, are you remember? If they said, if any element belongs to 5th period and 15th group. If any element belongs to 5th period and 15th group. That is Np5 and the 18th group general electronic configuration is Ns2, Np6. Understand? So this is all about the general configurations. Okay, number of valence electron here is 1, here is 2, here 3, 4, 5, 6. Valence electron. So we are not considering this one as a valence electron because S substitution is already completed. Okay, unpaired electrons or unpaired orbitals are considered as what? Valence electrons. Here is 1 valence, here 2, here 3, 4, 5, 6. Based on this, we are going to calculate what? The oxidation state, whether it is a +1 or -1 like that. Understand? So completely this. So if you want to consider total valence electron means that is 3, here it is 4, here it is 5, here it is 6, 7, 8. Total number of electrons in the valence shell. Valence means lost. Understand? Valence means lost. So listen, if any nucleus is there, this is S orbital, P orbital, D orbital and F orbital. After that, again S orbital will come. S, P, D, F. After that, again S orbital. Understand? Because listen, 1s, after that 2s, 2p will write. Next 3s, 3p will write. Next 4s, 3d, 4p. This way you know, I think so. Okay? 4s, 3d, 4p. Later, 5s, 4d, 5p. When 6s come, the F is 4f, 5p, 6p. Okay? So here listen. When S and P orbital valence shell is same like Ns only. Correct? When 4s comes, in between 4s and 4p, D orbital is 3d. If we consider 6s and 6p, here F orbital is 4. If n, we are considering this S orbital as n is equal to 4 means, this 3d orbital means that is n minus 1, 3. N is equal to 4 we consider means, then d orbital become what? N minus 1. Okay? So listen, here you consider, if n is equal to 6, S orbital is equal to n. P orbital also, P also is equal to n, because 6 is 6p. If we consider n is equal to 6. Okay? Next, here d orbital is what? 5 means n minus 1. F orbital means 4. F means that is n minus 2. Understand? So these are inner orbitals, not valence shells. This one is called as penultimate shell, anti-penultimate shell. These two are valence shell. So later I will explain. Periodic friends are there. No? So while I will explaining the atomic size, ionic size, everything I will explain this. Okay? So just now you remember only this valence electronic configuration, group-wise basis. Understand? So this is group-wise configuration. Complete P-block configuration is this. Okay, students? And remember, here, the 13th group elements oxidation state is +3. Okay, and right here. Group 13, 14, 15, 16, 17, 18. Okay, here valence electron. Okay, general electronic configuration I already wrote, so that's why I won't repeat it again. Okay, you simply write here general electronic configuration, you write yourself like Ns2, Np1 like that. Okay, by yourself write. Next one is valence electron. For boron it is 3, here 4, 5, 6, 7, 8. 8 means it is also 0. There is no valence electron, it is completely filled. 8 or 0. Okay. Next, oxidation state. So here it is +3, here plus or -4, -3, -2, -1, 0. Okay. +3, plus or -4, -3, -2, -1, 0. Understand? So here, listen, when it comes to the names, particular names, this 16th group elements are called as chalcogens. Okay? 16th group elements are called as what? Chalcogens. And 17th group elements are called as halogens. Okay? And these 18 group elements are called as noble gases. Okay? Inert gases, rare gases. Okay? So these are called as what? Rare gases, inert gases and noble gases. And remember one thing, the 18 group elements all are gases only. All are gaseous in state. Understand? Rare gas, inert gas and noble gas. Why they called like so? So listen. Why these elements are called as chalcogens means, according to a Greek word, chalco means oxide. Okay? According to this, Greek word chalco means oxide, gen means synthesis. Understand? So the 16th group elements forms a stable oxides. That's why they called as chalcogens. Okay? 16th group elements forms stable oxides. That's why they called as what? Chalcogens. Next, why it is called as halogens means? Halo means salt. So in a Greek word, chalco means oxide, gen means synthesis. So these forms stable oxide means, that's why they are called as what? Chalcogens. So 17th group element, aloe means salt. Okay, gen means synthesis. Okay, so you know, any salt you consider like NaCl is there, KCl is there, Ki is there, Na is there, those are all called as what? Salts. Iodine salt, chloride salt, normal salt, rock salt, you know, table salt. So everything consists of what? These halogens are the anions like fluorine, Cl, Br, iodine, acidity. Okay, so these elements form a salt with metals. So they form as salts. That's why they are called as what? Halogens. Aloe means salt, gen means synthesis. So these are salt general. So these elements react with metals to form a respective salts. That's why they are called as halogens. Understand? And next one is these noble gases. Why they are so in this? Remember one thing is among these halogens, this bromine is a liquid non-metal. So bromine is liquid instead. The one mark they may ask you students, which one is the liquid non-metals? That is bromine. Understand? So and another one thing they'll ask, why it is liquid instead? Okay? Why it is liquid instead? Are metal they may ask mercury, okay, cesium, or this bromine? They may ask why they are exist in liquid state. Because the simple thing is the room temperature is 25 degrees Celsius or 27 degrees Celsius, you know that, the standard temperature. So the boiling point of these elements is less than room temperature, that's why they are liquid in state. That is the simple thing. Because in the NEET examination they are going to ask why these exist in a liquid state at the room temperature. Why they are in liquid means because at room temperature they melts. Understand? So that's next one is this 18 group elements. They are called as rare, inert as well as noble gases. Understand students? Why they are called as noble gases means noble means precious. You know the Nobel Prize? Someone only the special and precious persons they are awarded. Okay, noble means precious. These elements are very less abundant in the nature. Okay, so which one the availability is very less means of course they become very precious. Okay, that's why they are called as noble gases because their availability is very less, their abundance is very less in the atmosphere. And next, rare gases also same. Their availability is very less, that's why they are called as rare gases. Understand? And the next one is inert gases. Why they are called as inert gases? Because listen, their configuration is completely filled, NH2 NP6. There is no unpaired electron in this. Completely filled configuration is there. NH2 NP6 means they are highly stable. Understand? And next year, oxidation state of groups is zero because they don't have the ability to gain an electron or to remove an electron. So they are neither losing an electron nor accepting an electron. Their oxidation state is zero. That means they are highly stable. So they cannot easily react with other. Inert means what? Which is not affected by anything. Okay, that's why these are called as inert gases. So among these students, the very abundant noble gas is argon. Okay, only the abundant noble gas is argon. And next one is if anyone with xenon means Xc. Okay, if this noble gas also forms some amount of compounds, only the known compounds are from xenon. Xenon has the capacity to form only few compounds because they have the capacity to exhibit +2, +4, +6 oxidation state. It has the capacity to lose +2, 2 electrons, 4 electrons as well as 6 electrons. That's why only this xenon shows some countable, okay, number of compounds. Only xenon. Understand? And argon is the abundant noble gas. Understand? So this is all about the p block elements. S and p block elements are called as main block elements because they decide the valence electrons of the configuration. Okay, so this is the general electronic configuration of S block. This is the general electronic configuration of P block. Okay, so the next one is the D block element. Okay, so students, this S and P block elements we are going to study in a group manner, like first group, second group, 13th group, like that. Okay, and remember one thing. All these elements, these first group elements are also called as lithium family. The second group elements are also called as beryllium family. This is as boron family, carbon family, nitrogen, oxygen, chlorine, and helium family, like that. The first group element of the respective group tells about what the remaining elements. So this is boron family means all the family members are same, right? Like that, it is boron means all the remaining elements also exhibit the properties like boron's family. Understand? So the next one is D block element. So students, here the D block elements are placed in the middle of the periodic table. Total 1, 2, 3, 4, 5, 6, 7, 8, 9. Total 10 groups are there. Okay, start from third, fourth, fifth, sixth, seventh, 8, 9, 10, 11, 12. Group number 3 to group number 12 are called as D block elements. So students, here they studied as scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. Okay, so these D block elements studied in horizontal rows, means in series. So these are called as what? 3D series, 4D series, 5D series, and 6D series. And F block elements are also studied like 4F series and 5F series because they exhibit similar properties along series than in group. So S and P block elements studied in groups, the D and F block elements are studied in series. Okay, so in the next class, I'll explain you about the configuration of the D block elements, how they behave, why they're called as a different oxidation state, everything I'll try to explain in the next class. Okay, thank you.